In this video, we'll start to learn about routers and how they can be used to connect multiple layer 2 segments to one another. So here is our local area network, and we talked about the fact that we can have multiple switches and that we can connect multiple switches to one another. And we can do what's called daisy chaining, and we can have multiple switches that are all connected to each other. And basically, as we connect these switches to each other, they basically act as if they're one big switch. And so the more switches that we connect, the more computers that we have in our layer 2 network, in our Ethernet network, the larger our MAC address tables start to get, the larger our broadcast domain becomes, right? So for example, let's think about an ARP request when we have multiple switches connected to one another. Let's say that this computer issues an ARP request, which is a broadcast. Well, that ARP request is going to be flooded out every single port connected to this switch. And it's also going to be forwarded to all of these other switches as well. And all of these other switches are also going to broadcast it out every single port that they are connected to. And so, as you get these broadcasts, they result in just a whole ton of traffic. And every single computer connected to every single switch port may at times be generating broadcasts. And so the number of broadcasts on my network can get out of control as the network gets larger. And there's a limit to the size of these Ethernet networks. So at some point, we have to start breaking them up into smaller Ethernet networks. That's what a router can do for us. So let's keep this simple at first. Let's eliminate all of those other switches, and let's say that we just have 2 switches. And rather than connecting these switches to each other, we want to break up our layer 2 broadcast domain. So we are going to use a router between them. And each switch is going to be connected to an interface on the router. And so at this point, our diagram is really starting to change. We now have 2 different Ethernet segments. And so on the left, we have segment 1. And I'm going to call that segment 10.1.1.x/24. That's the subnet associated with segment 1. And if you're not familiar with a subnet just yet, that's okay. We're going to talk about them more in the next lesson. On the right-hand side, we have a different Ethernet segment, segment 2, which is 10.1.2.x. And so the computers in each of these segments will have IP addresses that exist within their respective subnets. And so now you can see I've updated my diagram a little bit. Instead of just calling these addresses IP1 and IP2 and IP3 and IP4, I've actually assigned IP addresses to each of these machines, and those IP addresses exist within their respective subnets. Okay, so what is the impact of this? Well, let's start with broadcasts. Let's start with Ethernet layer 2 broadcasts. So computer 1, let's say it sends out an ARP request. And the ARP request is a broadcast, a layer 2 Ethernet broadcast, that is basically trying to determine the MAC address associated with a particular IP. Well, when a switch receives a layer 2 broadcast, it forwards it out every single port that it is connected to. And so it forwards it to the other computers it's connected to, and a copy of that layer 2 broadcast also is forwarded to this router. That's where the broadcast ends. The router says, okay, well, this is a layer 2 broadcast. That is only relevant on that particular segment. Therefore, it does not forward the broadcast to the other Ethernet segment. So by putting a router in the middle, we now have 2 different broadcast domains. This segment is a broadcast domain, and this segment is a separate broadcast domain. And the other impact is that this switch, let's call this one switch 1. Switch 1 does not need to know about the MAC addresses that are connected to switch 2, and vice versa. Switch 2 does not need to know about the MAC addresses that are connected to switch 1, because they are separate Ethernet networks. So by separating these 2 switches, by putting a router in the middle of them, I've cut my broadcast domain in half, and I've also reduced the size of the MAC address tables on these two switches. And so now that I've got a router in the middle of my equation here, how does traffic work? Let's say that computer 1 wants to communicate to computer 3. So computer 1 knows the destination IP address, and it generates what we call an IP packet. The IP packet is destined for 10.1.2.13. Well, how does it know where to send it on its Ethernet network? It knows about the destination IP. What's the destination MAC? It still has to communicate using layer 2. It has to get that traffic to the router before the traffic can get to computer 3. Well, the way that it does that is it uses the TCP IP stack of the computer to send traffic to its default gateway. So what do we mean by a default gateway? Well, this router here has its own network interfaces, and those network interfaces are connected to the respective switches. And so computer 1 can communicate with this router. This router has a MAC address that is known to this switch, and the router also has an IP address as well. And that IP address is going to be the default gateway for this segment. So each one of these router interfaces has a unique IP address. And so on segment 1, let's assume that we have a router interface connected to segment 1, and that the IP address of that router interface is 10.1.1.1. And we also have a router interface connected to segment 2, and that IP address is 10.1.2.1. Now, if computer 1 needs to communicate with computer 3, it's going to send some traffic to the 10.1.2.13 address. And the operating system of this computer is going to recognize, hey, 10.1.2.anything, that's on a different network. That's not on my local segment. And so the operating system will say, if this destination is not on my local segment, I need to send it to something that can reach those other segments. I need to send it to the default gateway. And so again, here we are in my command prompt for my computer. I'm just going to type in the ipconfig command. And notice what we see here in ipconfig. We've got an IP address for my default gateway and a MAC address for my default gateway. So if my computer needs to send some traffic to some other layer 2 Ethernet segment, it's going to send it to this IP and this MAC. That's the default gateway. And once that traffic arrives at the default gateway, the router knows what to do with it. The router has interfaces on both of these segments, so it has connectivity to both of those subnets. And so when the router receives a packet that is destined for 10.1.2.13, it can make a routing decision. It can say, if I need to get to 10.1.2.13, I need to forward it out the interface that is connected to that network segment. That's what a router does. It makes routing decisions based on layer 3 IP addresses. And one of the behaviors of a router is that it understands the networks that it's directly connected to. So this router has an interface on the 10.1.1.x network. It knows how to get to that network. It has an interface on the 10.1.2 network. It knows how to get to that network. And those directly connected networks are automatically included in the route table of this router. Okay, so let's take a brief moment to do a short review of what we just learned. Routers break up layer 2 networks. And what we essentially mean by that is they create a layer 3 boundary between layer 2 networks. So broadcasts don't go across a router. Routers do not forward layer 2 broadcasts. Each layer 2 segment has its own unique IP address range, its own IP subnet. And like I just mentioned, those routers, they don't pass along those layer 2 broadcasts. So that's one of the ways that they break up those layer 2 networks. The other thing is they reduce the size of the MAC address tables. The router is the default gateway. So all of the computers that are in those subnets, they're going to use the interface on the router as their default gateway. And we also learned that routers will automatically establish routes for directly connected networks. So a router automatically knows how to send traffic to the networks that it's directly connected to.